Welcome back to College Algebra, Properties of Exponents. This is the third video, and not hopefully, it will be the last video, I promise, on Properties of Exponents. So remember, and we've talked so far about properties of exponents and how to use them to simplify. We've also, on the last video, the second video, learned about how rational exponents are similar to integer exponents. We learned about all these properties that are still the same. It's just that now we have to worry about common denominators and such. In this video, we'll talk about how rational exponents are different to integer exponents. And in particular, here is the biggest difference. If you have a number, so let's say a is a number, but it's not 0. And in fact, just to be safe, let's make a positive number. Then this number to the 1 over n, we're going to say from now on, it's the nth root of a. This is the big idea. And to give you a reason as to why this is true, I want you to think about the square root of 2. Remember that if you take the square root of 2 and you square it, you're going to get 2. In fact, just to make it a little bit more clear, I also want you to think about the cube root of 2. You know now that if you take a cube root and you cube it, they sort of cancel each other out, and so you'll get 2. And so what I want to show you is the following, is the fact that if you take 2 to the 1/2 and raise it to the second power, because of the properties of exponents that you learned in the last video, you know that all you have to do here is multiply these two numbers. Take the 2 and multiply it times the half. And we know that 1/2 times 2 is 1. And so we get 2 to the first power. Again, your properties of exponents, you know this is 2. Now if you look over here, at this problem, let's write this as 2 to the 1/3. Notice that if you cube it, again, we need to take the cubed and multiply it times the 1/3. And so we'll get 2 to the 1/3 times 3. But 1/3 times 3, when you multiply these guys, you're going to get 1. So you get 2 to the first power again. But again, we know that 2 to the first power is 2. Notice that we got the same answer in both. So when we squared, well, what I want you to notice more than anything is when we squared the square root, we got 2. When we squared 2 to the 1/2, we got 2. When we cubed the cube root, we got 2. When we cubed the 1/3, we got 2. And this is the reason why, or at least an example as the reason why as to why we make this definition. So we continue. We even go a little bit further. We actually say the following. We say that, and what I want to draw your attention to is here in radical notation. This is the part that's going to be extremely useful to us, is that if you ever have m over n as a power, okay, there's two ways to think about this. You could take the nth root of the number first, so you can take the nth root of a and then raise it to the nth power, or, so this is one option, or option number 2, you can take a to the nth power and then take the nth root. And so in the examples I'm going to put on next, we'll try one or the other depending on what makes it easier. And again, what makes this a little bit tough is the fact that there's more than one way to think about this. And so hopefully you're flexible enough that you can think of it in both ways. So here's our first example. We're going to simplify this expression. We're going to assume the variables represent any real number. So first off, we notice that there's a negative exponent. So we understand now that negative exponents mean the reciprocal. So the way I want you to think about this is say, oh, I want the reciprocal of negative 27th. But now this exponent that was negative becomes positive. So now it's 2/3. Now here's where I need to think about what I just wrote in the last slide. There's two ways to think about it. My favorite way is to take the root first and then square. So the way I think about this is I first say, the bottom number is cubed. Since it's cubed, I'm going to do a cube root. What am I cube rooting? Well, I'm cube rooting the negative 27. So I'm going to write that in here. But then there's another part. There's a square right here. So I'm going to go ahead and square that answer. So that's how I think about this. So I first take the cube root of negative 27. So I do the bottom number first. That's always a root. And the top number is always a power. And so I would try to color coordinate so that hopefully this helps. And so the first thing I do is take the cube root of negative 27. And I know the cube root of negative 27 is negative 3. But I still have my square. I still have to square that answer. And then I know that negative 3 times negative 3 is 9, so the answer here is 1/9. Okay, so this is one way to think about this. A different way that you could have thought about it, but I think it makes it a little bit tougher. So I'm gonna actually write it over here to this side. Is that you could have said, oh, let me square first. Let me take the let me take the negative 27 and let me square it. But then after I've squared it, I want to take the cube root of it. This is also fine. The one reason I don't like this, I guess the reason I don't do it this way is because I have to square 27, and that could be a very large number, and then I have to know the cube root, and I might not know the cube root of a very large number. So I prefer to always take roots first, because then that makes the number smaller, and then I can square smaller numbers, and that's a lot easier. So that's at least the way I think about this. I'll show you a different example. So here, another negative power. So again, first thing I notice is that this power is negative, so I'm going to go ahead and use the reciprocal property. So I'm going to say, this is just 64 divided by 27x cubed, and now the power becomes positive, so I can write it as 2/3, like that. Okay, so now what? Well, now I distribute, I guess, this power, or I make sure that everything inside the radical has this power. I shouldn't say distribute, actually, but that means I have 64 to the 2/3. I also have 27 to the 2/3, and then I have x cubed to the 2/3. And so the numbers, again, I like to do the cube root first. I like to do this part first. And so what I'll do is it's the cube root of 64, but then I'm going to square that after I do that. So I'm going to square this. Then it's the cube root of 27, but then I'm going to square that because it says square right here. And finally, this part the variables are actually, I think, are the easiest, because this I just have to do x cubed, and I have to multiply the 3 times the 2/3. So that's not too bad. This is I can do, because then what I can do is put 3 over 1 and just do cross canceling, and that'll work out nicely. But what about the numbers? Well, the cube root of 64 I know is 4, but then I have to square that, so we can't forget the square. Then here, the cube root of 27, in the last slide we saw that it was 3, so I go ahead and put 3, but then I have to square that. And then the variables, well, that's okay. 3 over 1 times 2/3, like I said, these 3's cancel, so I'm left with x squared. And now everything gets squared here, so it's going to be 16 over 9x squared, and that would be my answer. All right, one last example. There's a negative out high. That's the only difference, but otherwise, same process. The negative exponent tells me to do the reciprocal. So I'll write this negative, but I only, well, it's not going to matter, but I do the reciprocal of what's inside. So 8 over x to the 9th to the 4/3. Then this 4/3 is only affecting what's inside the parentheses, which means that only the stuff that's inside the parentheses needs to have the exponent. There's going to be 8 to the 4/3, and it's going to be x to the 9th to the 4/3. Okay, so let me scroll down a little bit. So again, I like to do the bottom number first. It tells me to do a cube root. So this is equal to negative. I'm going to have my cube root here of 8, but then I have a 4, so I got to raise this to the 4th power. Now, the bottom, I'm going to multiply. I like the variables better, because then here it's x to the 9th. You can think of it as 9 over 1 times the 4/3. All right. So now, again, I'm going to scroll down a little bit. Oh, I guess I can't. Sorry. And the cube root of 8, well, that's 2. So this is equal to negative 2. But I have to raise that to the 4th power. And then here, 3 goes into 3 once, and 3 goes into 9 3, so it's 3 times 4 is 12, so this is x to the 12th power. And then finally, I just have to say, well, 2 to the 4th, I know 2 times 2 times 2 times 2, that's 16, and it's x to the 12th. And that would be my final answer. Okay, well, this concludes our videos on properties of exponents. Hopefully this makes sense. If not, come to class, or when you come to class, I'll be able to answer any questions that you may have.